The first was actually when I was working at Ball Aerospace in college. I was working in this group that had, they made cameras that bolt on the side of satellites. They look at the stars, they're called star trackers, and they figure out the angular displacement of all the stars in the scene. They can figure out exactly where that thing is pointed, like to the 100th of an arc second or something. And so they were doing these simulations of star images, because a star looks roughly Gaussian once you project it onto a CCD, by doing like photon simulations of like the star is here, so we're going to do a Gaussian just by doing a random function, and we're going to photon by photon fill this software-based CCD simulation. And it would take 20 hours to generate a single scene. And I was asked to make this faster, and I went down that road. I'm like, okay, we can make the RAND function faster, or maybe the math could be faster, or something like this. And then I had kind of an aha moment where it's like, oh, wait a second, this is just the wrong algorithm. If you looked at it and you said, I want a distributed Gaussian across this array of pixels, I could do it by using a RAND function, or I could pre-compute an integral of a Gaussian and take 2 points and subtract them, and I know my pixel value. And because the Gaussian is separable in 2D, that's a really fast operation. So it went from 20 hours to like 100th of a second. And so to generate these scenes, and so that the lesson there was, you will in your career be asked to sort of make these optimizations. Don't go into it with a preconceived idea of okay, I start from here and I go to there. It's really important to stand back and take a look at the algorithm and think, hey, could this have been achieved with some other math? It's one of the reasons why math is so critical for DSP engineers. But that was a huge lesson for me. So now whenever I optimize something, I may run it under a profiler, but I don't usually dive deep until I try to understand the bigger picture. So huge learning moment for me.